This is Britt Caswell with another video example. In this example, I am covering lesson 1-6, example number 2, in the SavvasRealize Algebra 1 textbook. In this example, we are covering compound inequalities involving OR. So that means that we are looking for the solutions that satisfy one or the other inequality. Okay? So it doesn't have to satisfy both. It could work either for the blue inequality I have marked or the red inequality. So the way I always start these problems is we always want an inequality where you just have the x isolated or by itself. So I am going to take these inequalities and I'm actually going to start just by solving them. Okay, just to get a single numerical answer that I can plot on the number line. So I'm going to go ahead and draw my little river down from my inequality symbol. Okay, that helps me to remember when I need to cross the river using inverse operations. So let's start with the blue one. Right now the x has something being multiplied to it and it has something being subtracted from it. So to get the x alone, I'm actually going to go about dealing with the subtraction first. So the inverse operation is subtracting. To move it across the river is to add by 7. So my problem now turns into 5x is less than 13 plus 7 is 20. Now when you have a number and a letter that are squished together like these are, this is a form of multiplication. So to unmultiply, or the inverse operation of multiplication, is division. So I'm dividing by 5. So here I get x is less than, and then 20 divided by 5 is 4. Now we'll graph that here in just a moment, but let's go ahead and let's do the red one first. So here on our red one, again we have multiplication and then addition or subtraction. So I have to get rid of the addition before I can use inverse operations on multiplication. So the opposite of adding is subtracting. So I'll subtract 3 from both sides. So I get negative 4x is greater than 8. And then when you have a letter and number squished together, that's multiplication. So I'm going to divide by negative 4. Now remember, when you multiply or divide by a negative number, this inequality, he freaks out and he changes directions. Just remember, alligators get really stressed out with negative numbers. Okay, so he got confused and turned the other way. So on this side, I still have an x, and then 8 divided by negative 4 is negative 2. So these are the two inequalities that I'm going to look at graphing. Now the thing is that my solution can work for either of these situations, okay? So here's my number line. I'm going to make it count by twos so I don't have to draw as many lines. So for my blue one, I have x is less than 4. So I'm going to go ahead and put my endpoint at 4. And I look to see if I need to shade it or keep it empty. My inequality does not say it can be equal to. So because there's no line under here, I keep this hollow. And then x is less than 4 goes this way. So there's my blue one. Now let's go ahead and let's take a look at the red one. Now the red one says x is less than negative 2. So I would go ahead and I'd be putting my point here at negative 2. And it would be a hollow point because it's not equal to. But do you see how, oh, and then I'd shade to the left. So the red one would go like this. But do you see how this red one is kind of contained in the blue one? So because the red one is a portion of the blue one, and it's already satisfied by having graphed the blue one, I don't want to put the endpoint on here. Because if I put that red endpoint on there, it's going to look like I'm doing all the numbers less than 4 except for -2, because there'd be a hollow circle there. Okay, so this is kind of what my graph would look like. This one's kind of a special case. Most of the time, I'd say probably about 90% of the time, or graphs look like this with 2 arrows pointing in other directions. But sometimes, very, very rarely, they'll overlap like this. Okay? Usually, I see when they overlap like this, and I think I might have made a mistake, and so that tells me to usually check and make sure I really did it closely. Okay? I'm not saying that it is wrong. Okay, this one is correct. But sometimes it could be. Okay? So now let's take a look at example 2. Okay, this one's a little bit more traditional. So I have 2 inequalities. Okay, I have this yellow one, -3x plus 2 is greater than -7. And I have this brown one, 2 times x minus 2 is greater than or equal to 6. And we just start by solving them just like normal. So I'm going to draw my little river. This one's a green river. Has a lot of algae. Down from my inequality symbol. This one's just like up above, right? There's multiplication and addition. So I need to get rid of that addition first by subtracting by 2. So this turns into -3x is greater than -7 minus 2 is -9. And remember, a number and a letter squished together like that is multiplication. So to undo that inverse operation is division. And if I'm multiplying or dividing by a negative operation, remember that inequality goes that way. He changes directions. And that gives me x is less than -9 divided by -3 is 3. Now if I now go to the brown one, okay, the brown one starts with a set of parentheses. Okay, so it's a little more complex, right? We want to get rid of the parentheses before we add or divide or anything like that. Okay, so I'm going to distribute the 2 to each value in those parentheses. So 2 times x is 2x, and 2 times -2 is -4. And then the process works just like the other examples. So I have to get rid of my addition or subtraction first. So to remove this -4, my inverse operation is adding 4. So I have 2x is greater than or equal to 10. And then this here is multiplication. So to undo that multiplication, I'm going to divide by 2. So I get x is greater than or equal to 5. So when I go to create my number line, I'm not going to go hog wild with my numbers. I'm just going to have the number just outside of 2, or sorry, just outside of the 3, and then just outside of the 5. Okay, so I have a nice range to show where my shading is. So for my yellow one, I know I have an endpoint here at 3. My inequality symbol says it's less than, but it doesn't say it can be equal to, so don't shade it in. Keep it as an empty circle. And then x is less than 3 would shade here to the right, or I'm sorry, to the left. So there's the graph of my yellow solution. Now on my brown one, I know my endpoint is at 5. It says it's greater than or equal to, so that endpoint needs to be filled in. So there I've shaded it. And it says x is greater than that 5, so it's going to be shading to the right for the greater than values. So because this is an OR situation, these solutions work on either the yellow line or the brown line. Okay, so if I'm describing this, I could say this is all real numbers except those between 3 and 5. Should write the number 5. So those between 3 and 5, including 5, right? So 5's included. So that's a way to say it using words. Or I could say it in words, it's all the numbers less than 3, or all the numbers greater than or equal to 5. That's a way to say it in words. All right, so there's a couple ways we can describe this. Okay, don't go thinking if you describe it one way that it's not right. All right, and ooh, sorry for the fading here, but that is example number 2. Until next time.